So in parts A and B, we focused on calculating the bubble point and the dew point pressures, right, for a given temperature. For parts C and D, we now want to flip that, and we want to find the temperatures that correspond to the bubble point and the dew point. And we're given a total pressure here. So in part C, we're going to calculate the bubble point temperature. Okay? And so here, for C, for P is equal to 760 milligrams of mercury, which is about 1 bar for now, I'll just say. Okay? What we're going to do to calculate this bubble point is we're going to go back to equation 1, which was that combined Dalton's and modified Raoult's law. So P is equal to x1 gamma 1 P1 sat plus 1 minus x1 gamma 2 P2 sat. Okay? All right, and so the thing I want to point out here is, we want to find, we're given a pressure, so we know P, and what we want to find are temperature. And temperature in this equation is going to be buried not only in the vapor pressure equations via the Antoine's equation, but it's also going to be in our activity coefficients, right? Because if we go back here, we know our activity coefficients have this A value in there, and A is going to be equal to A naught over RT. So both the gammas and the vapor pressures are functions of temperature. So since gamma I and Pi sat are functions of T, right, what we have is a very nonlinear equation that we need to solve. Okay? And so to solve it, once again, we have to turn to iteration. Right? And so we just have to do a root finding sort of calculation. So T root of the following objective function. So your f obj, that's just going to be equal to x1 gamma 1 p1 sat plus 1 minus x1 gamma 2 p2 sat minus p, right? Where your gammas are here, and then for your p sats, you would use Antoine's equation. Okay? All right, and so you would find the temperature that minimizes this objective function, and essentially that temperature root that you find would correspond to T bubble. Okay? All right, and then once you have that temperature root, what you would do next is your Y1 equation. If you rearrange your modified Raoult's law, you would get this. And once you have the bubble point temperature, you could plug that back into gamma 1 and P1 sat to find Y1. All right, and so you could implement this root finding sort of calculation into MATLAB. And if you do that, you should get a bubble point temperature of about 75 or 70.55 degrees Celsius and a bubble point vapor composition of 0.59.